Hello everyone. In this video, we are going to talk about how to configure packet truncation in Cisco Nexus Data Broker controller. For this demonstration, I'm using NDB version 3.10.4 and a supported NXOS version and NXOS switch. We're going to talk about why packet truncation is needed, especially in the packet brokers, in the context of packet visibility, and what are the various approaches we have for enabling the packet truncation in Cisco NDB. And we'll dig deep into how to configure the source ports and the tool ports and the truncation port configuration in the context of packet truncation, and we'll get familiarized with all these terminologies in the due course, and how to stitch them all together into one place and create a connection. And we'll see how the configurations are enabled on the NXOS switch and take a dig deep into the terminology to understand how this feature works. Before we begin exploring what are the various methods we have to enable the packet truncation on the Cisco NDB, first let us get a little hang about why you need a packet truncation on the packet brokers. Especially, there are some types of tools where the tools are charged based on the bandwidth you utilize. And there are some analytical engines which are just interested in the headers of the network packets. And there are wide variety of reasons why you don't need a whole packet to be sent out to the tools. So giving this as a context, it's very important in the packet brokers to truncate the packets before ingesting them to the tool ports. May it be saving the bandwidth, may it be making convenience for the analytical tools to just run the analysis out of the packet headers. This is the driving reason why you should think about truncating your packets before ingesting to the tool ports. Well, these are the three methods what we have to enable the packet truncation on Cisco NDB switches. The method one, it's just familiarizing ourselves with the terminology, right? So here the source port is Ethernet 1/37, and I have a tool which is connected to Ethernet 1/5. The primary use case is take all the packets from 37, truncate it, and then send it to the tool port. For doing the truncation on the tool connected on Ethernet 1/5, we need an intermediate port in this case, which is called Ethernet 1/3, and we call it as a truncation port. And the responsibility is to make it up, make it layer 2 up. So what we do in this approach one or a method one is we connect Ethernet 1/3 to some other dummy switch or any other switch that is available in the data center to make sure that Ethernet 1/3 is layer 2 up. That's a method one. And in the method two, what we do is we identify some other port on the same NDB switch to make sure Ethernet 1/3 is up. Again, Ethernet 1/37 is a source port, and Ethernet 1/5 is a tool port, and Ethernet 1/3 is the truncation port. The way how we make Ethernet 1/3 up in this method is to connect it to another port on the same NDB switch. In this case, we can probably choose 4, or we can choose 7, 8, 9, and whatever port it can be. And make sure that the other port what we choose to make Ethernet 1/3 up should be configured as a layer 3 port. Now let's come to the method 3. It's a little innovative way of making Ethernet 1/3 up, which is called a self loopback modules, which are widely available in any network store. You can probably try it in fs.com, or there are so many self loopback modules which are even available on Amazon or any other network vendor related e-commerce tools. The same example here, we got packets coming on Ethernet 1/37, and we want to truncate them and then send it to the tool. And we have Ethernet 1/3 as the truncation port. And the way how we make Ethernet 1/3 is, in this case, we don't need to identify a dummy switch like method 1, or we don't need to burn any other port like method 2. And what we do is we buy the self loopback module and insert it into Ethernet 1/3. Now the Ethernet 1/3 is automatically up because of the self loopback module. So these are the three varieties we have to enable packet truncation. By the way, please be aware there are some optimizations going on in the NXOS in the future releases, and without even having Ethernet 1/3, there is a possibility of we truncate the packet on the ingress itself, or right before the packets are ingested into the tool with the new features that are coming up in the future. But this video just focuses on the incumbent way that it is delivered today with 3.10.4 for enabling packet truncation. Now, coming to the configurations on the NDB controller UI, as we outlined, Ethernet 1/37 is a source port where we are getting the whole raw packets from tap or a span. Ethernet 1/37 on 104.cisco.com switch. So how we are configuring that is we configure it as a span port, and now once after this configuration is done, this port is ready to get the raw packets on Ethernet 1/37. Right after configuring the source port, now we are configuring the tool port. Our tools are connected on Ethernet 1/5, and it could be a regular tool which needs just the headers, or some analytical engines, or a tool which charges you based on the bandwidth. So it can be any category tools. Eventually, this tool just needs a specified number of bytes. It could be as low as 64 bytes, or it could be as high as 1500 bytes. Based on the requirements, we are going to configure it as a tool. Ethernet 1/5 is a tool. As we outlined in the previous slides about the approaches, our end goal, either through using approach 1, approach 2, or approach 3, is to make Ethernet 1/3 up. In this, Ethernet 1/3 is called a packet truncation port, and we configured it as a packet truncation port as shown in the slide. So once after configuring the Ethernet 1/37 as a source port and 5 as a tool port, if you log into the NDB switch, this is how the configurations will look like on the source port and on the tool port. Well, this is the place where exactly the truncation is going to happen. So Ethernet 1/5 is where the tool is connected, and Ethernet 1/3 is the port which need to be up, and it's called a packet truncation port. So what we do is, when you create a truncation feature on the NDB controller, it's going to create a local monitoring session on the NDB switch. And this is how exactly the session will look like. It's a local monitoring session, and the type of the session is local, and the state should be up. And here what we do is, the source interface for the session is Ethernet 1/3, and the destination for the session is Ethernet 1/5. So what exactly we do is, in the transit of the packets from 3 to 5, we truncate it. And there is something called MTU. Here I'm truncating the packets through 320 bytes from the start of the packet. So no matter what is the size of the raw packets coming on the source port, what we do is, by the time the packets go to Ethernet 1/5, we truncate the packet to 320 bytes and then ingest into the Ethernet 1/5 where the tool is connected. This is how we create a connection, and the name of the connection in this case is C1. What exactly it does is take the packets on 37 and send it to the tool port. And based on the connection parameters, what we do is We take the filter and filter out all the packets, send it to the packet truncation port, which is Ethernet 1/3 in this case, and the span session is going to take care of taking the packets from 3 and then ingesting into the 5 where the tool is connected. That's the reason it is also called span truncation. Once the packets are truncated, the NXOS switch will take care of recalculating the CRC checksum and ensure the packet is all well constructed after the truncation before handing it to Ethernet 1/5, or in other words, the tool. This is one simple example how you can examine if the packet is all constructed right and it got a right checksum post truncation. And this capture is just going to illustrate that in this example, we truncated the packet to 192 bytes. As you can see, the frame size is 192 and the packet is all good and the checksum is all added properly post truncation. And based on the switch what you select and based on the truncation parameters what you give, and it can vary all the way from 64 to 1500 bytes. Depends on the switch what you have, depends on the NXOS what you're running, and depends on the MTU settings what you do. You can expect the packets to be truncated to that size before handing off to the tool port. Thank you.